Hey guys, this is the high school scientist, and in this video we shall take a look at energy. To be clear, there is no possible way of explaining energy in a short video. In fact, it would take hours or even days to explain energy in detail. So all I'm going to show you guys is what energy is and help you to form an idea of how it behaves. So in simple terms, energy is just force times distance. Well, that's what your textbook says. But I like to call energy as the fundamental currency of the universe. And this currency is measured in joules. I mean, the unit of energy is joules. Now, energy can be classified in two types: kinetic energy and potential energy. And when we combine both of them together, we get the total energy of a system. And this total energy remains constant. It's always the same. So what I mean by this is energy cannot be created nor destroyed. It can only be transformed from one form to another. So for example, when a ball is dropped from a height, the ball bounces back. Why exactly does this happen? And by the way, Newton's third law is not an answer. Well, at least not a complete answer. So to drop the ball from that height, you first have to take it there. And when you do so, the ball gains some potential energy. And when it's released, the potential energy starts converting back to kinetic energy. So as the ball falls, the potential energy which is contained inside that ball slowly starts converting back to kinetic energy. At impact, the ball transfers some energy to the ground. But why doesn't it transfer all its energy to the ground? Because there is not enough time. The ball immediately bounces back after impact. And this is where the kinetic energy of the ball, which is maximum at impact, starts converting back to potential energy as the ball goes up. And this cycle continues until the ball loses all its energy to its surroundings and becomes stable. Now this is one way of describing energy. In fact, there are many different cases in which energy changes from one form to another. For example, when you burn something, the energy released is from the chemical reaction which takes place inside the substance. The potential energy which is present inside the substance in the form of atomic bonds gets released when these bonds break, and we experience the released energy as heat. When you charge your phone, the electric potential energy is used to shift the chemicals in the battery and store them as chemical energy. And when you use your smartphone, the chemical energy is converted back to electric energy to turn on your display and fire up your speakers so that you can watch funny cat videos. And not only that, but everything in this universe is made up of energy. According to Einstein's famous equation, E is equal to mc square, which states that all matter is made up of energy. So then why don't we use a unit of energy to describe the world around us? The reason is that it becomes really hard to express everything in terms of energy. And that's why we have to use different units and various types of measuring instruments to better understand the world around us. Now, on the topic of energy, we have to talk about the conservation of energy, where energy is conserved every time it changes. So nothing is lost and nothing is gained. Remember the ball we talked about a few minutes ago? That time I did not mention how much energy is needed. And did you think about the amount of energy released when the ball is dropped? Well, the energy required to bring the ball up depends upon three things: the mass of the ball, the height from which you would like to drop the ball, and gravity. Now, if the ball is really heavy, then it would require a lot of energy to bring it up. And the reason why height matters is because if you want to take the ball really high, then you would have to spend a lot of energy to take the ball up there. And third, gravity. How strong gravity is. Well, if you were on moon, it would not require a lot of energy to take the ball to a certain height because the gravity is really weak. And so these are the factors which determine how much energy is required to bring the ball to a certain height. Now the question which still remains unanswered is how much energy will be released while the ball is being dropped. Actually, none of it is released when the ball is dropped. The potential energy is just converted to kinetic energy as the ball descends, and only on impact, the energy from the ball escapes in the form of sound or friction from the ground. And by the way, energy is also transferred when the ball pushes the air molecules around it. Now, in all of these rapid transformations of energy, none of it is ever lost. The lost energy that you think of is just converted into something else. Okay, that's fine. Now you know that potential energy is energy stored in an object, but what if the object is in motion? How do you find the energy of a moving object? Now this kind of energy is called kinetic energy, and we can find the kinetic energy of an object by multiplying the mass of the object with the half of velocity square with which the object is traveling. I will be showing you the way in which I derived this equation in my future videos, so subscribe and hit the bell icon. So in conclusion, kinetic energy is the energy which is involved in the motion of an object, and potential energy is the energy contained in that object. Thus, the total energy of a system depends upon kinetic energy and potential energy of that system. Okay, so now that you understand what energy is, let me tell you the way it works. Now, every particle in the universe likes to be in the lowest possible energy level. It likes to be stable, and that's why everything around us tries to get rid of as much energy as possible. And this is the reason why hot objects eventually cool, water flows down from an height, and the reason why people grow old and die. So now that you understand what energy is, you would probably like to know that everything in the universe is made up of energy. Atoms, molecules, subatomic particles. In short, everything that has mass is made up of pure energy. And if something has no mass, then that thing is pure energy itself. The sun emits 384.6 trillion terajoules every single second. You can literally move the earth with that much energy. And if you focus all that energy to a single point, you can create a black hole and destroy the sun itself. But after all this discussion, what energy boils down to is just a number, which when you have large amounts of it together, you experience different properties of energy, like mass and gravity. So I guess this is probably enough to make you think about energy, and if you are, then please consider subscribing and just spread the word, let your friends and classmates know about this channel. This is the High School Scientist, signing off.